Kia ora Year 12 and Year 13. I'm going to make this video for Devesh, which is to go over question 3 in Mr. Haring's worksheet on describing the features of trig graphs. I'm going to go one step further than what you were asked to do on the worksheet. I'm going to identify the features and then I'm going to write the equation. And we're going to write both a cosine model and a sine model for this one. Now I've only done one question here. If you're getting stuck on the other ones, just flick me an email and I can do a few more. But I think once you get the hang of it, you should be fine to do all of them. When we write a trig model, we're looking for figuring out the value of 4 different parameters, right? This one here is the amplitude. This is the vertical shift, D. This is my horizontal shift. And this is my horizontal stretch. The order that I always do these in is, first of all, I do the vertical shift, the amplitude, and the period, because they're usually pretty easy. From the period, I'm going to get the frequency, and the frequency will be 2 pi divided by the period of this curve. Okay, and lastly, I'm going to work out the horizontal shift. In this particular case, there's no reason to prefer a cosine model over a sine model because we're going to need a horizontal shift, whichever of those two models we choose. Okay, let's start by looking at the, let's get rid of doing the period here first. Sorry, Saturday night, guys, and brain's going very slowly. So the period is, what is one full cycle? So in this case, the period will be 1.0472 plus 0.5236, right? So I'm measuring this distance here. That works out to be 1.5708, and as we discussed in class, we're going to get that as a fraction of pi. So that's 1/2 of pi, or pi on 2. And that means that usually in a cosine or a sine model, we'll have one cycle takes 2 pi to work through, but here we're going to get 4 full cycles in 2 pi. And that means that B will be 4. Next, let's look at the vertical shift. So to find the vertical shift, I need to think about the halfway mark between the 6 and the -2. So if we whack a ruler in there, you can visualize what's going on more easily. D, the vertical shift, will be halfway between 6 and -2, which is 2. So my vertical shift is 2 units. So 2 units up. Next, the amplitude, which is the distance from the midline up to the top. And that distance will be 6 minus 2, so 4. Right? So we can see that that full distance there is 8, -2 up to 6. So the amplitude is half of that. But Devesh, you didn't want any of that. You could do all of that already. All you really wanted me to do was the horizontal shift. So finally, I'm going to get to it. Right, so the horizontal shift in here, if we're modeling it with a cosine model, goes like this. Let's take our ruler, and this time we're going to put our ruler in roughly where x equals 0. Okay, so x equals 0, probably around here. You won't have to do this once you get going, but it's not a bad thing to do to start with. Okay, so if we're looking at this here, if we're modeling this with a cosine model, my standard cosine graph starts here, right? That's the top there. The maximum is at 0. But in our cosine model, you can see that the maximum has been shifted out here. So it's been shifted to the right by 1.0472 units. And that's what my horizontal shift number is. So my equation for this one is going to look like this. Y is equal to 4 cos of 4 x minus 1.0472 plus 2. Right, so again, we've got amplitude of 4, a vertical shift of 2 units up. We've got a frequency of 4. And the last thing we have to say is that we've got a horizontal shift, 1.0472 units to the right. Now that's not a unique solution, right? Because I could also have done it and said, well, let's think about this as my starting point, right? It just doesn't matter. That's the whole point about trig graphs. Okay, they repeat after one period. So the other way that I could have written that was to say that my horizontal shift is left by that many units. We could have written the model as y equals 4 cos of 4x plus whatever that number is, 0.5236 plus 2. Okay, so that's doing it all with a cosine model. If I do this with a sine model, I just have one little extra step. We'll just take all of those off. And again, it's quite useful to put in the ruler. So we'll put the ruler in roughly through halfway. And this time we're looking for where is the starting point of the sine curve. So the starting point of the sine curve is about here. So it's about the halfway point. I really need to draw this better. Let's just try again. So this value here is the minimum and this is the maximum. The starting point of the sine curve needs to be halfway between those two values, right? So here's my basic sine curve. I'm trying to map this onto this. So I need to find the coordinates of that point, and it's whatever that x value is. So that's not hard to do because it's going to be halfway between this one and this one. So 0.2618 plus 1.0472 divided by 2 gives me 0.6545. So if I'm using a sine model to do this, the period, the amplitude, and the vertical shift are going to stay the same, but my function is going to be y equals 4 sine 4 times x minus 0.6545 plus 2. Okay, so that's using a sine model to do it. Now, if you're watching this and you're not getting why we've got a minus sign here when I'm shifting in the positive direction, you can see it by taking the value of 0.6545 and substituting it in here, right? And that's going to work well because that gives me 0 in here, right? So to make this be 0, I need to have the minus sign here. If I had a plus sign, I'd have some stupid number like 1.3 something, something, something. Okay, so always be careful checking the direction of your horizontal shifts. It's definitely a place that you can go wrong without practice. Okay, Devesh, sorry that took 8 minutes to answer your pretty straightforward question. Email me if you've got more questions. Otherwise, I will post the solutions to that worksheet sometime tomorrow. Thanks for watching.